any of them repeat? So that means that we are in a good spot. That is a function. Same thing for this side. We have input as x, output as y. Do any of those repeat?
Yes.
What repeat?
2.
So that's why it's not a function. Any questions? Everybody still with me? A function is a special relationship where every input has only one output. Meaning exactly what we just said. Every x is used only once. So x can't what? X cannot repeat. Everybody still with me? I don't agree with this next statement, but it was put on here. A fun way to remember is 2 cheating on his girlfriend in the first example. No, because he only has 1. Is 2 cheating on his girlfriend in the second example? Yes, because there's 2. He's dating 7 and 3. I do not condone this example, but if it's there, to each his own. So that is not a functional relationship. You can't have 2 relationships going on at the same time and expect both of them to be healthy. Any questions? We only care about the X column. Only check to see if X is cheating, not Y. Use the definition of a function and the examples above to determine if the relations are functions. Looking at letter A, it's this first table. What values am I looking at?
0.
X. So what are my X values?
7, -2, 0, 4, 9, -2, 0.
Do any of them repeat?
Yes.
What?
0.
So is this a function?
Not
So we could put not a function. What values am I focusing on for B? So what are they?
3, 1, 2, 0, 1, 2, 5.
Do we see any cheating happening?
Yes.
Who's cheating? 2. So is or is not a function? Not a function. Looking at C, what values am I looking at?
-8, 4, 11, 6, -8.
Do we see any cheating?
Yes.
Who's cheating?
-8.
But is it actually cheating? No, because Y is both what? So we have to look at the y-axis, yes? So just because you see it repeating doesn't mean you should not go and look, because sometimes they do put doubles on a table. Does that make sense? So is this a function?
Yes.
Yes, so we can say function. If you need more clarification, what I just said is that little box right there that I just highlighted. Looking at D, what am I focusing on? X, which is what? Buttons, right? Because if you push the button, that determines what candy you're getting, right? Do I see function or not a function? Why do you say that? Because the 2, not the 1, because 1s are still both what? The sticks, right? But what are the 2s? M&Ms and duds. So we can't do that. Is that a function? Nope, not a function. Any questions on determining functions from tables? Now we're talking about the vertical line test. We've seen this before, right? So imagine a vertical line drawn through a graph. If the vertical line touches the graph only at one point, it is a function. If it touches more than one point, it's not a function. So very quickly, I'm just going to highlight this. You see how I'm making the vertical lines on the paper that are already there a little bit more obvious? It only hit that point, that point, that point, and that point. So it only hit the graph at one point. So this is a function. But if I looked at this one, at the lines I drew, we can see that it hits more than once in more than one place. But all you need is one example of it doing it. It hit it more than once, which made this not a function. Things we've already seen. Nothing new. Not really. So we're going to go through these vertical line test examples up here, okay? Shouldn't take us long. Is number 1 a function? No, because at what x value do we see it repeat? At -1. It's right there. That's why we said no. What about number 2? Yes, because none of them repeat. What about number 3? Yes, because do any of them repeat? What about 4? No, because if I draw one line right there, how many times does it hit it? What about 5? Again, one line tells me it hits it how many times? And what about 6? Yes, because it doesn't matter what I draw, it's going to hit it once. Any questions? How do we feel?